Welcome to this mid-afternoon presentation. We're going to try and keep you awake for the next hour. Mid-afternoon after a good lunch, maybe a few late nights. We'll see what we can do to help you stay awake. We're going to talk about Dockerizing a Windows application, or Windows applications, but using an existing partner application as a case study and as the basis for this discussion. My name is Thomas Hansen from appSolution, and my partner in crime today,
Bronco Oostermeyers without the S. I already explained that in a previous session. From Flusso and long time OpenEdge, enthusiast, I would call myself.
Yeah, just very briefly, I've worked with OpenEdge since 1995, so I'm one of the younger people in the crowd with OpenEdge. Primarily working with OpenEdge consulting. Actually worked with Docker and containers since it came out. It actually came out at the end of 2013, but since 2014, as far as I can remember. A lot of my focus has been on application lifecycle management, and lately on DevOps, which covers a lot of ground, and spend a lot of time working with automating OpenEdge and various things related to that. So Roundtable and Roundtable automation has been one of my key focuses. I also spend a lot of time working together with Julian Linden-Smith from Notable on the Securable product that he's also been presenting at this conference. Actually worked both for Progress, for appSolution now, and also until recently for Notable. We'll soon be launching a new online platform called Absolute Knowledge with some online courses that might be interesting for people related to OpenEdge and other things.
So that's my slide. Only a year shorter than you actually. So still a newbie as well. Everything with Progress, and more recently I'm acquainting myself with Docker, Kubernetes. Docker for actually quite a few years already. Kubernetes, which is basically a deployment platform for Docker containers. Some identity management via Keycloak, which is a little bit of a competition for whatever Thomas is doing, but recently acquainted myself with Go, because that goes pretty good with the likes of Docker and Kubernetes. Did some UI stuff as well, but tried to keep away from it because the server side is more interesting to me. And work for Progress Services in the Netherlands. I work for a company called Unit 4 and Walvis, for whoever may know that. And since 2014, consultant for Flusso. Well, Flusso, we're a consultant, so that's pretty overseeable. So I'm a consultant as well over there, and most of the time doing the presentations to represent my company, or the company I work for. It's not actually my company.
All right, good. Okay, so we're going to talk about containerizing or Dockerizing, and one of the key things is why would you want to do that? Now, Bronco covered some of that in his previous presentation, but we're just going to run through some of the reasons or some of the pros of going into a containerized world. One of them is the ease of building and integrating into your DevOps pipeline. So automated builds of your Docker images, which are really the foundation for the applications you're going to be building. And the fact that you can build and have snapshots of applications, databases, different components that make up your application on specific branches or versions of your code in your application. It's fast, it's repeatable, it's a very good way of having something that is easy to reference, and where you can, for example, test multiple versions of OpenEdge with the same application code simply by having images that are pre-built with that. For testing purposes, it's incredibly easy to spin up a stack or spin up containers, do something with them, run against your database with your code, with specific versions of OpenEdge, and when you're done, throw it away. One of the key things is you get consistency, because you've got images that are pre-built snapshots, so you're always using the same thing. So people who are testing, people who are developing, people who are testing, and also when you're deploying your application, if you're doing it in exactly the same way and using the same images, then you know that the content of what you're running is the same as well. Deployment, it's very easy and fast to deploy. The difficult part about all this stuff is really what we're going to be talking about in this presentation, is putting all the Lego blocks or all the building blocks together so that you can build your application stacks and put the different components together. But once you have that, it's very easy to fire up either single instances of applications or maybe clusters of, where you've got multiple instances of things like PASOE or front-end components, and we'll talk a bit about that today as well. Load balancing becomes so much easier because spinning up instances that are part of a load-balanced environment is very easy. And deploying applications that are in containers is much, much faster than deploying anything on a virtual machine. You can do a lot more automated, which gives you less errors, less work, and less support to be doing as well. Scalability. With containers, you can very easily scale your applications. You can deploy your applications across multiple hosts, regions. So there's a lot of different things there, depending on what kind of platforms you deploy on, and we'll cover some of that in the presentation as well. Flexibility, you can run on different platforms, different environments, on-premise. You can run build your stacks and test them on, if you have a Windows machine, which some people have, you might have the Windows subsystem for Linux installed on that, so you can run Docker Desktop and actually run your stack as part of your development environment. You could be running everything in a browser in containers with containers inside it. And if you want to hear how that or see how that works, come and see the presentation we're doing tomorrow on that topic. But then you can also run stuff on hosts in your either on-premise, in the cloud, use different cloud-based services that are specifically geared towards running containerized workloads as well. It becomes incredibly easy to integrate your applications with other technologies when you're working with things that are built in containers, because you've got these building blocks of predefined, pre-built, pre-configured applications, and there are thousands of equivalent things for other technologies out there. You don't have to install an Apache server or a Nginx server or some other more complicated stuff and get it up and running and configure it so you can use it together with your application. All of that becomes very easy, and you can test things very quickly and very easily. So new configurations, it's quick and easy to install and set up. We're going to talk a bit about recipes for starting up your container stacks. Using Docker Compose is going to be the primary focus of what we talk about here, but we also have things like something called Helm charts, which are recipes that are used for deploying applications into a Kubernetes cluster. And with these recipes, you pull the right images depending on whether or not they're available already in your local environment, start containers with custom settings, and all of that happens pretty much instantaneously. And the other thing is that containers are very lightweight compared to virtual machines. One of the other reasons for looking at a project like this one is Windows dependencies, and that was really one of the challenges with this particular project, was that we had an application that was really built on Windows, for Windows, without any consideration for any other platforms existing. So everything was Windows-based, which meant the code and a lot of other things. And when we move things into containers, and especially go through the effort of moving them from a very Windows-centric environment into Linux containers that are in that way more flexible, we get away from some dependencies on Windows infrastructure and the more heavy VMs and installations that you might need to make just to run something on Windows. And we're going to be talking also about why we needed to move from the application from a Windows deployment environment into Linux and therefore and then into containers, because that's a key part of this, especially when we're talking OpenEdge. Resource usage. One of the key things, Bronco also covered that in his initial presentation on Docker, is that containers use a lot less resource. We can fire up multiple clusters on the same machine. We can very easily get multiple instances and copies of the same machines or of the same application on one individual machine. And that way we can make use of the resources that we have available a lot better than if we were running stuff and installing it directly on the hosts. Okay, so a Windows application Docker journey, one of the things that we needed to do to get started with this is actually a project that's been very high on the wish list for a progress partner in Scandinavia, in Copenhagen, called Mark Information, that we've been working with on a consulting project for a long time, and getting their Windows application, which has really been, they've been working on that since the mid-90s, on various versions of OpenEdge, and keeping up with all the latest technology and all the latest tools from Progress, and implementing lots of different stuff there, but everything has been on Windows. And that meant that we couldn't just take the application, put them into containers and start setting it up and firing up stacks of containers, because we had code that was written without really looking at things like a case of files or case of run statements or execution statements, references to include files for those which are being used in here. So one of the first things we needed to do was start looking at the code base and seeing what is needed, and this is what anybody will need to do to take a Windows application or any application, is look at the code structure and see, does it first of all run on Linux? Does it compile on Linux? And if it does, is it going to run? Well, if you don't have that in place, then that's probably the first big hurdle that you've got to cover. And that's part of what we needed to do here, is go in and look at the code, then look at the structure of their PASOE instances, how they were setting them up. There may be some things that were best practice when you initially defined your PASOE setup, which when we're going into containers may not make so much sense. One of the things that we came across in this particular setup was having multiple web applications within the same PASOE application, which can be a good idea in some cases, but when we're wanting to containerize stuff and make little units that we can put together as we need them, it makes a lot more sense to be splitting things into individual instances. And then really working from there, trying to get a demo set up where we had the different components of the application up and running, and illustrate very quickly how, once we'd done some work, and Bronco's going to talk about some of the complexities from a code analysis point of view and refactoring the code to run in containers. But from there, we could very easily get to a point where we can fire up parts of the application running in containers, running, for example, with a PASOE instance, where we can, whether we run 1 or 3 or 5 instances of a PASOE instance, it's a question of how many containers we start up. We don't need to be setting up multiple virtual machines and configure different instances of PASOE on there. And then the next bit is really, once we can we've proven that we have everything up and running, is then really going into a deeper dive into the code and looking at what are the different more intricate things that need to be changed, Windows-specific code, DLL calls, .NET code, references to hard-coded paths, and all sorts of other weird and wonderful things that you come across when you look at old application code like this. So part of this Docker journey, as we call it, is also then to look at, well, PASOE was the initial focus point, but we've got other parts of the application as well. And in this particular case, the customer is looking at migrating the next generation of the application is going to be a cloud-based application that they want to be running up on Microsoft Azure in as scalable and as flexible a model as possible, and fully containerizing the application in all of the different components will give them the biggest bang for the buck there, because that means they can make better use of cloud resources, they can deploy application instances for new customers much quicker without the maintenance and resource usage overhead that they otherwise have. So it's a question of looking at, what are the front-end components? Are there other PASOE components? Look at the database, for example. What can we do there? We can't officially run the database in production, but we can certainly look at some things with regards to development and testing, and then getting that implemented, getting it tested, deploying something we can use, and rinse and repeat that until we have a good, stable stable setup that could be used as the next generation of the application. And you'll see the Docker whale here with the Christmas hat on here. That's because the expectation is on this particular project that we have an alpha release ready for Christmas, which is a Christmas present for the boss of the company that we're working on here. Right, so just a very little about Docker images that are available and that we can use. And this is also something that Bronco touched on. We have a couple of official images available from Progress. We have a PASOE runtime that you can use to, once you've built and designed your application, you can create runtime images that you can run your application with, but they're exclusively built for runtime. So you can't do compiles, you can't do builds, you can't do anything. You have to have everything pre-built and pre-compiled so you can package it into a runtime image. Databases, you can build images and run images for databases, but they're only supported for development and testing and for builds and those kinds of things. So officially, there's no support for running databases in production. Whether or not that's a good idea, that's a fairly long topic that we can take over a couple of beers this evening if anybody wants to pick up on that topic. So what we always end up doing is we need some Docker images to actually do builds and do compiles and do some other stuff. The images from Progress are black boxes where we don't know how they've built them because we don't have the Docker files that describe the recipe for how these images have been built. So we always end up creating our own generic multi-purpose OpenEdge image, which is either built on CentOS or on Ubuntu, and where we have multiple versions of Progress available. And these images we can use to run databases, we can run PASOE instances, we can run build processes, we can compile stuff, we can do all sorts of cool and weird and wonderful things with that. And that's actually one of the components that's missing in the official images that are available from Progress. But we need that for this kind of project to be able to work with that. Databases, we can create pre-built snapshots of databases, either just with schema or with content, so that we can go in and spin up a database on a specific version with specific content to work with. That's something that we need both for development, building, testing, and so on, and for our initial proof of concepts. And once we have our containers stuff up, one of the things we can do, this is sort of looking at across a development environment where you start off having your typical Windows development tools. You've got Developer Studio, you've got some different Windows components, you've got Visual Studio Code. But once you start getting your database and your PASOE and some other things into containers, you can move that onto into your Linux containers, and you can actually set it up so that, for example, Progress Developer Studio is connecting to the database that's running in Docker. You could be exposing the content of the file system you're working on through a Samba share in a Docker container if you want, and you've got your PASOE that's running in containers as well. So it's a nice way of getting a hybrid environment that you can work with. Right, so I'm going to pass on to Bronco to talk more about some of the more nerdy stuff that we've been through.
That's where I kick in. Forgot to put on my t-shirt, I suppose.
That's too late. Yeah,
Thomas already mentioned some of the topics I'm going to discuss concerning the first thing you actually do when you want to Dockerize a Windows application is just Linuxify it. Well, it's an ugly word, but I guess you know what I mean. It has to be you have to be able to run it on Linux, and not only run it on Linux, but compile it on Linux as well. And there are some challenges to that, and the most obvious candidates are include files, which are programmed with backslashes, but there are other stuff as well. Get key values in any files, for example. So there's all sorts of stuff why software you have developed on Windows wouldn't work. Backslashes in itself are a problem, not because they're not only being read, but if they're not prefixed by tilde, then it's treated as an escape character on Linux. Very great. Try to get those out of your code. The OS command stuff, if you do a CMD, OS command CMD whatever, then that's not going to work on Linux. And I won't even, the obvious ones like the Windows specific calls for .NET and handy glasses. But one of the first thing is, basically there's a compile time side on it, and there's a runtime part of it. And first, let's focus a little bit on the compilation stuff. The challenge we had, that we had some, I think, 4,000 source codes, pieces of sources, around a lot of thousands, and they're basically in 3 directories. And that included old UI stuff and the logic and the REST logic and the web handlers, and everything was in 3 directories. So actually trying to find out what you need to compile was already a challenge, because everything was just one bunch. Then of course you run into, well, once you have come up with a decent set, can I compile it? I talked about the include. The UI code, do I want to compile the UI code? No, I don't, because I don't have any purpose for that. So the first attempt was, okay, what have I started? There were too many errors. So at first there was this impression, well, before I entered the project, we can change this by hand. And everybody knew this was a pretty daunting task, but there was the impression that we could do it by hand. But I am lazy, so what I did, when we compile, we use the end scripts. And the end scripts, which you made, have a compile task, and one of the things the compile task is actually able to do is to specify a file which states the includes, the excludes, so the files you don't want to compile. Now, if you go search in all your source codes and you search for, what do we here? For all the classes which has a resx file accompanying, then you know it's a UI screen. If there's a resx file, it's a .NET UI screen. But for the same thing, is if you look into the code, if you see using system whatever, you know it's not going to compile because there's .NET in it. Telerik, same thing. Infragistics, same thing. So what we did here is just create a bash script, and in this case it looks pretty scary, but once you get your head around it, it's pretty easy. What we did here is, this is one of the pieces which generates the exclude file, which is later used to exclude all the compile files. So once we start a compile, we run this script, and this script outputs an exclude file, and we use that one for the compilation. So all these stuff which is either a resx file or using system whatever, Telerik or Infragistics, are automatically excluded. And that was, if you can exclude like 500 or 600 sources, that automatically it helps. This is bash, just not to scare you away, but if you're used to Windows scripting, but you want to move your application to Linux, learn bash. Bash is incredibly powerful, and it is the scripting language of choice on your target environment. So there's another thing to learn, but you need to do, I suppose. One of the other things is casing, of course. Later on I'll show you an example of what we actually encountered, but when you look at it from a compilation point of view, the casing of the include files is relevant as well, because sdo.i, for example, is not the same as sdo.i in capital. So making sure that all the files and all the references have the actual, the correct case is a challenge in itself as well. And there as well, we use bash scripting to search for all the references and just and make sure that they were corrected accordingly within, well, I think with this approach covers for about 99%, and there's always some stuff left. But if you're talking about thousands of files, that's worth the effort, because it's a little bit early to conclusion. But basically, what we did here is, well, what did I do? 4 days of hacking, and then I got this topic pretty much covered. When you look for the when you have a thing like grep on Linux, it's incredibly powerful just to come up with whatever situation you have to evaluate. Well, what I did was, for example, we have to evaluate run statements. This is not going to hurt you at compilation time, but in runtime it's going to hurt you. And you know it up front, so you know that if you want to have some sort of reasonable code base to work on, you have to fix the run statements. So with that I do a grep case insensitive of whatever run.p, because the .p's are the external .p's, are going to potentially an issue. So you end up with a list of, well, this one states up until line 15,000, so we grepped for run.p's and we ended up with at least 15,000 sources. Well, try to do that by hand. It's impossible. So one of the things, well, these are pretty obvious examples. We have a run enable.p in lowercase, we have a run enable.p in uppercase, and at first what we did is, okay, we see the .p, we try to establish what case it actually was in and then convert it to that case. Later on we switched from attitude, we said, okay, what we're going to do is we're going to everything in lowercase. It was a bit of a shock for some people, except for the classes, by the way. But all the .p's and all the .i's are all in lowercase. Classes are actually, well,
file names.
Yeah, the file names of the class, yeah, and therefore the class names.
But not all the code. We're not getting that far.
Well, so now we have the results of the grep, and then I created a fix.p, and this outputs just a real bunch of files, because when you're dealing with so much changes, you want to know upfront what you're doing. So I ended up with a couple of different files. For example, which ones do I reject? So if I look at a line and I see there's a comment in front, I don't need to do anything about it, so I reject it. But the next things are, what do I leave unchanged? Because it's already in the correct case. What am I going to change? Here there's a file which contains actual case of the file, which wasn't a big deal anymore because we knew at the end we're going to convert everything to lowercase, but at that time it was important. And we ended up with a run.p fix case shell script, which pretty much looked like this. It took set is my big friend, and this is basically in file replacement. It says, okay, the first part is what are you looking for, the second part is what should it be, and the third part is in which file do you want to execute this. And this seems a little bit clumsy because there's really lots you could say, well, you could turn down, but the reason why I put everything in there is just to avoid false positives, because you never know what you're going to hit. And when the similar approach I took for these .i's, and down there are the numbers we were actually running. So for the run statements, we evaluated almost 15,000 run statements. We ignored 5,000, but we ended up with 10,000 changes in more than 1,000 files. Well, try to do that manually. Apart from the fact that manual labor is tedious, it's cumbersome, and it's error-prone. And when I rerun the script, I still have 50 cases left. So somehow there's an error in the script. But imagine what you get some pretty unmotivated employees or co-workers if you have to do this manually. Same part for the include. Actually 32,000 evaluated cases with in the end, well, not so many file changes, but still. So every file we changed got 10 includes, which is quite a lot. Now, then we had a code base which was pretty much compilable.
That doesn't guarantee it runs, but it compiles.
Yeah, sure.
So that's the first step.
Well, which is the first step which satisfies us. Because the proof in the pudding was actually the running, but we should be able to run something first. So then we started shifting this to Docker. Okay, what does it take to take this to Docker? So we compiled every stuff, we built the PL files, and then we started creating our own containers, which contained OpenEdge. we had to bring in Java because Java is no longer brought into the equation by Progress itself, but it is an explicit step. We had to create a PAS instance and the applications overall, of course. What we didn't do, and what I covered in my previous presentation, is that you don't want your license files in the containers, because if you start to distribute these containers, maybe these license files are customer specific, and once they're in your images, they never get out of your image again. So no license files into the image. At first we did our own images, completely from top to bottom. And then we started to move to the ones PSC provides. They're a little bit smaller, and they deleted a lot of stuff in all sorts of directories of the DLC directory you don't need. And it's nice for political reasons. Progress likes if you use their stuff, but you don't need to install OpenEdge because it's already there. And we could concentrate on what is actually important. That is the application, not OpenEdge, but it's the application is what we want. Well, so the top line says we use our the Progress software PAS4OE image. We are on the latest LTS version, so no 12.4. We're waiting anxiously for the next 12, the next LTS release, and no clue what version that's going to be, but haven't heard a decent answer yet. And then we started, the next block is copying in the WAR files. And the WAR files is basically just a zip file for Tomcat. So what does it do? You put everything your application is put in there, and you put it in the web apps directory, and when Tomcat starts or deploys the directory, it gets unpacked, and then your application is there. Once we have those in place, we start to create the instance, because the installation is there. You got your OpenEdge installation in your container for your image, but you don't have a PAS instance yet. So, no, well, if we look at this, we see we parameterize a lot of stuff because you want to be flexible, and you can inject all the variables from outside insert. So this way you keep your images generic, or your Docker files generic, so you can reuse them and you don't have to go all over them. And then we start to do the usual stuff. I want to say something about my log files. I want my agent starter parameter, which obviously connects to the database, those kind of stuff. And we ended up with the Docker file of, I think, well, somewhere around 100 lines, so it's still quite a lot. And it depends on, once you start using Docker, I think you look differently on what you do with your PAS instances, because when you do it manually, it's okay, like I. But when you want to repeat it, you want to keep it as simple as possible, because, yeah, well, I think it's a good idea anyway. So, for example, maybe you don't want these endless Docker files, and maybe you want to keep it a little bit simpler, but these are the steps which were necessary, and they had an installer, a Wise installer, which is kind of, well, it is, which took an MSI and created this PAS instance on virtual machines, and we took that as an inspiration to come up with the Docker file, because these were the steps they were doing in their Wise installer, and now we're doing it in the Docker files. So there's basically a one-on-one relation to what they were already doing and what we are doing right now in Docker. Okay, we have the compilation artifacts, we have the image, then we have to build it. This is basically how you build. So this is basically turning your Docker file, which is your recipe, into an image. And an image is something you can deploy both locally or centrally in a registry. These registries, well, I call this the Pro Summit Azure Container Registry.io, which basically means that I send my copy of my image sent to Microsoft, and Thomas can sit on his laptop, and if he has the right credentials to access this one, he can then download the entire image and just run the application identically to what I do or whatever is happening on any server. These containers, these images should be as generic as possible. Anything which is customer specific should be injected via either volumes or configuration files or whatever. But don't put anything specific into containers because once it's in there, you can get it out of there. And one of the good things is, it's a mindset. So you want to be able to run one image for all your customers. And whatever is specific, you inject it in it, but you make sure it's not up there in front, because otherwise you end up with 50 images if you have 50 customers, and that's what you don't want. Because once you test it in one setup, you know that the exact same setup is used for customer 2 and customer 3, and the only variable is the configuration file or whatever you inject into it. It's important. Well, then we have to think about how we're going to run it, and this looks like a pretty simplified version, and it is quite simple because we have a load balancer on top. We have n instances, and n doesn't matter. It can be 1, can be 2, or it can be 10. And we have the database. It does imply something it has some implications, however. If you look at this picture from an authentication point of view, you can ask yourself, what can I do with authentication? If you have OA realm authentication, which basically means you have a class here, a 4GL class, and that creates your session and your client principal, it's only valid on this instance. So you got a stateful token. But if you want to have load balancers, the nice thing of load balancers is that it actually is able to round robin whatever instance is available, and it's good for failover as well, because if this one starts to ill behave, because of the memory leaks Tom already mentioned in his previous session, if this gets above 2 gigabytes, for example, you say, okay, we'll just throw it away. But it's not going to work if your stateful token is only valid on this instance. So one of the takeaways is use stateless tokens. And stateless tokens, one of the biggest examples, the most used examples are JWTs. So, and there a product like Securitable kicks in, because those are the things which can issue a JWT in a manner that you also can verify whether the token is issued is actually a valid one, because anyone can throw a token, but you have to verify it as well. So Securitable is one option. Flusso, we use Keycloak for that, but JWT tokens are stateless. So everything which makes up the session is in the token, and this token is valid in this, and this, this. So if you throw down this instance, it's not a problem. You can easily throw it away, and the user doesn't notice anything, because if you have stateful tokens and you throw away the instance, then the user has to re-log in, and has lost basically everything.
Spring security in PASOE supports that, so it's very easy. If you've got an authentication mechanism like Securitable or Keycloak or Azure AD or something like that, then Spring will automatically take that JWT token and include that in the client principal that gets created for your progress session, so that all the back-end stuff works. So you can do some pretty smart things on that.
Yeah, JWT sounds a little bit weird, but in the end, what Spring Security does is take the information in the JWT, and it's just a JSON file, or JSON information, and converts that into a client principal. So once you're in the 4GL, you're on familiar grounds again, and you can use whatever you are already dealing with in your client principal. This is a good addition. Now, the reason why I said this, of course, is that this may seem pretty simple, but once you start thinking about, okay, how do I want to deploy my application? The customer we were working for has on-premise customers. They have customers which run on virtual machines, either in the cloud or not. And right now we are thinking about deploying it on Kubernetes. So the simple architectural pattern which we encounter, we come up with in the previous slide, along with the stateless session tokens, makes all these kind of things possible. And this is basically a matrix on what the subjects which are in play are routing. So which way do I need to go? Do I go to PAS instance 1, 2, or 3, or do I go to the app server, or do I hit my UI? Because that's all on the same URL. The topic can be load balancer. Well, we covered just, but the backend as well. The backend can be just a virtual machine. It can be a physical piece of hardware. We combine it. We can do it in Kubernetes, in pods and containers, and everything is possible. All these combinations are possible once you get your head around this. Well, in the architectural issue. So, what we did to showcase it at the customer, because Kubernetes is nice and it's a little bit difficult, but we started with Docker Compose, and Docker Compose is just basically a way of tying all your containers together. And at first we had basically three. We had a database one, we had one for PAS, and we had one for the UI. And of course we had something for the load balancer as well. But you want to be able to tie this all together, because if you spin these up, you are able to combine these things together. Well, here we are looking at the Docker Compose file of what we actually do when we start the PAS container. So what am I running? What image am I running? What are my volumes? And volumes are the mechanism which, because what is in a container stays in a container. That's not always what you want. For example, your license should come out of the container, and but some log files are in the container, but you want to be able to access them from outside as well, maybe. And the same goes for your configuration. Configuration is on your host system, and it's not in your container, but your container needs it. So you need some mechanism to exchange those information, and that's done by volumes. The ports, these are the ports we are using. Basically, this is the the 8810 port we are used to for PAS. But we map what is in the container and what is out the container, because if you have 3 instances all running on the same port in the container, what do you do with the outside? You need to have something in place there, because on the host you can run 3 times the same port. It doesn't work. So you have to do some mapping of what is in the container, what's out of the container. We do that here with ports. And this is just a stack you can run. That's the other way around. Well, so far we basically only covered the OpenEdge part, so the database, the PAS instance, but this application has a web front end. You need to do something there as well. Yeah, sometimes now I make it feel like Docker could be hard, but sometimes very easy, because the image, the Docker file which creates the image for the UI contained about 5-6 lines. It just, okay, I start from Nginx, and here's my HTML code, run it. That's basically it. So it's like 6 lines, because you do have to say on what port you. So in 5 lines, in a Docker file of 5 lines, you can expose your UI with no Apache, Nginx or whatever installed on your machine. It just runs. Well, we had some challenge, well, not a challenge, but everything is pointed to one URL. So for example, poetsummit.org, whatever. And we have, if we do have /data, then it goes to PAS. And if it's just a slash, then we go to the UI. That has some certain advantages, because you don't run into coarse issues, but it's a little bit different subject, but it makes life easier. Keep on. With the same simple architectural pattern, we are able to set up massively complicated setups. And this is basically how it could look when you run it on Azure. Yeah. So you have various virtual machines, and these virtual machines all run a load balance setup of 3 PAS instances. So if you want to, for example, say I want to change my software here, I can just do it container by container. Without the entire virtual machine, the entire virtual machine, the node, is still available to the entire stack. So if you take away an entire node, it takes time to spin it up again. And spinning up Docker containers is a lot faster than spinning up entire virtual machines. So instead of just putting 1 PAS instance on a virtual machine, we ended up with 3. And so we have both at this level we have a load balancer, and over here we have a load balancer. But we did our homework, and because we did the stateless tokens, this is all possible. So you can grow from very simple to rather complicated stuff. And when it's getting this complicated, you're probably looking at other deployments than just virtual machines, and that's where Kubernetes come in. But I think that's for another story. Yeah, this is basically what we talked about. We have three parts. We have the database, we have the web UI, we have the PaaS instances, and this is what runs on the client. They're going to run it over the internet.
Well, one of the key things is you don't have to move everything. So you do if you want to get the full scalability of doing moving everything into the cloud. But in this case here, we're moving PASOE and the components that we can into the container layer. But we have some other services and some other things that are running on Windows that we need to keep there, at least until they've written, come up with replacements that are more cloud-based. So we end up with a hybrid environment as an intermediate setup.
Yeah, well, it's a sort of introduction of the next demo. We're going to run a Docker compose setup with everything. So this is what we showed the customer to actually show that we did do some valuable work where they paid for. And
so let's do some demos.
Yeah. Take it away.
All right. You want to hide away in the corner there?
Yep.
All right. So let's just quickly show what something like this looks like. So we actually logged onto a virtual machine on Microsoft Azure, and this is an environment where right now it's a Linux host with Docker on it. It's got a load balancer called Traffic, which is basically listens for containers that start up, and it is then able to load balance them based on different settings that we set in here. And one of the first things I'm going to do is I'm going to start a database. So I'm going to run an orchestration script we have, which basically starts up an instance of our database. And you'll see over here on the left-hand side, I'm connected to my Linux host with Visual Studio Code with an SSH connection. So I get an IDE that gives me, it's actually really nice to work with in that way. But it also has Docker support, so I can go in and work with that in here. And you'll see over here on the left-hand side, I've actually got a database image that started. I've got a whole bunch of ports here that have been exposed. I need to specify those. I need to specify the port for the database broker, and I need to specify minimum and maximum range for the database servers so that I can access those from services outside the database container. And I need to specify for, if I use something like a Postgres database, I need to specify one port. Here, I need to specify a lot more ports to make sure that even my PASOE instances that are going to be part of the same stack can talk to the database. Question?
You defined these ports when you did the Docker run, correct?
Yes, when we run. So it's not when we build the image, but it's when we run it. So it's part of the. We have some environment config files where we set that, but that's basically how that gets set up. And that exposes the port so that we can run them. I'm just going to bring up our portal, the web application. So this is an Angular web application. You'll see I'm getting another stack that starts up over here. And if I just jump over to this web UI for Traffic, the dashboard, and look at the HTTP services I have available, I have for what's called the Pro Portal, this is the load balancing information of the Pro Portal service, which maps to, if I look at the services for this, it maps to the actual, I have a single container where the container itself is running on port 80 because it's an Nginx server. But that's being mapped and it's being handled by Traffic as the front-end load balancer. I'm now going to go and start up a PASOE instance. So PASOE up. And when I do that, this is going to start up PASOE. You'll see that it starts up over here. It's going to This takes a little while to start up, and one of the things I can go in and look at here is I can actually go in and keep an eye on it and see, look at the files inside the container. So I can look at my application PAS installation directory, and I can actually go and look at all the log files, for example, and have a look at that and see what's actually happening inside the container, which is very useful. At the same time, if I go over to traffic and have a look here, I've got an HTTP service for my PAS instances here called ProMark REST. And if I look at that over here, you'll see I have a server here, a single instance of my PASOE, which is running on port 16010, which is the internal port that the PASOE instance is running on. And this is up and running. It's got a green tick on it because we're actually using health checks. Traffic is doing a health check against the PASOE instance to make sure that a specific REST service is available before it starts load balancing this. And that means I can then go and log on to my instance here if the app server is up. Come on. And I'm now actually logged on through a web browser to what's called the application gateway on Microsoft Azure, which is another load balancer that's doing health checks against my traffic instance, which is load balancing the PASOE stuff on the back end. And I have a single PASOE instance running on that. And this actually, if I log out and log back in again, I'll get a Microsoft prompt because we've also got Azure AD single sign-on configured as part of this. So if I just go back to this setup here, one of the cool things you can do with Docker Compose is I could go in and say I want to scale, whoops. So I'm going to scale my PASOE service in my Docker Compose file. I just want to scale one specific service. So in this case, it's going to be my PASOE instance. And I'm going to scale that from 1 to 3 instances. So if I go and have a look in, you'll see if we look at what's going on here on the Docker side, well, I'm getting I've got 3 instances running here. If I look on the traffic side here, I've got another 2 instances up and running. They're red at the moment because the PASOE part hasn't finished starting yet, and the REST APIs that I'm querying against for the health check are not available yet. And one of the challenges we have in this particular setup is that it takes about 2 minutes for each PASOE instance to come up and be available. And we're trying to work out how we can optimize that. But essentially what happens then is we get round-robin, load-balanced PASOE in multiple PASOE instances that are connecting to the same database. So we've almost instantaneously increased the capacity of our PASOE backend to provide services here. Yes?
So if I understand correctly, this is one VM and it has 4 containers, a traffic container and 3 PASOE containers?
It's actually got a traffic container, it's got a database container, it's got 3 PASOE instances, and it's got the web front end as well. So it's got the actual, all of those running on the same host as part of one stack. And if I refresh this, I should get green across the board here. And that means I can go in, and we don't have time for that now, but I could stop these instances. You'd see that the load balancing will be effective here. The other thing that's important is you'll see if each of these PASOE instances are being exposed, the internal port of the container is port 16010, 1611. So the PASOE instance is identical on all 3 instances. But when they start up, the port that gets mapped to the host are different, and traffic is picking that up and working out how to balance the traffic into those.
Sorry, do the containers register themselves as traffic?
Yeah, they start up. Actually, traffic is listing on the Docker daemon, on the socket for the Docker daemon, and then it checks for containers that have specific labels that we define to say, if this container starts up with this label and you try and address it with a certain host name or whatever rules you set, then make that available to that request. Yes?
The logic for defining those external ports are inside your ProMark Also in the script?
Those are inside the Docker compose script. So when we define, it may be a little difficult to see here because we are, well, actually here. What I'm saying here is expose port 16010 to 16011 dynamically,
Okay.
and then traffic and Docker do the rest.
They assign the external.
Yes, so they do all the dynamic mapping, and it would be really cool if we could get the Progress database to do the same thing. That all the dynamic ports that get allocated for the servers are made available in that way, or we had a single port as the point of entry into the database containers. That would be even neater. Right. So we've just got a few more things to cover. One of the things that, just sort of wrapping up this discussion, and part of what we've covered so far is really sort of the initial getting into and getting started with this project. And what we identified from this was what we've, in this project, we're calling technical debt for the stuff that needs to be done to not only just be running a proof of concept, but actually running their stuff in production. So we need to identify, first, we looked at, can we compile, can we run, what fails, what blows up, what are the things we need to refactor, and all the way down to functionality of the application, because there may be code that needs to be rewritten or restructured so that it works better in this kind of environment.
Thomas, there's a question on the chat that said, our code is portable between Windows and Linux. Why wouldn't we just move the dev environment right into from Windows to Linux?
Because of all of the stuff that's in the R code, so for file name references and run statements and backslashes and hard-coded directories to see temp, see Windows temp, and those kinds of things. Yep? Okay, so casing, coding conventions, these are all sort of summaries of the stuff that Bronco covered before. Windows-specific code. You could argue some of that you might want to move to .NET Core or something like that, but it might also be a good opportunity to look at some old code that you've maybe been carrying around for too long and looking at whether there are features and functionality that you should be maybe modernizing. Configuration management, this isn't Roundtable, this customer actually uses Roundtable for their version control. We use Roundtable and Bitbucket. But this is more things like config files, ini files, or using the Windows registry to get information from. Put this into, for example, JSON files instead, which are more mainstream and so much easier to work with across different platforms. Application artifacts. So look at the different processes we have for creating. So it's not just the code. It's the entire application lifecycle we're looking at. So we're looking at how we're generating WAR files, how we're storing those, what pipelines do we have in Jenkins or in some other CI/CD processes to create things, how we're creating procedure libraries. Can we start doing things, especially when we get things into containers, can we do things that are a little more independent of the specific build servers within their on-premise environments and so on. Things like security. We touched a bit about on that with Bronco was talking about the JWT tokens and about stateless tokens for your PASOE instance. But there may be other things where this is also an opportunity to look at. You need some more generic stuff for the Linux and the container support, but you may also want to introduce things like having more generic access to back-end authentication systems like Azure AD or OIDC sources or Google or something like that, using Securable or Keycloak or some other solutions out there. And next steps for a project like this, well, this is actually getting into rolling up our sleeves and actually getting stuff done now and getting the real work done so that we can get an application proof of concept up and running. We are at that stage right now, and we have that up and running, but now we need to do a lot more detailed testing and then look at having it load balanced. We actually just showed that, so we could very, very easily, once we had the initial proof of concept up and running, having something that's load balanced is even easier. It's incredibly easy because It's just a question of spinning up the containers that we need. And then looking at all the other containerization candidates or Dockerization candidates, web UIs, other PASOE components, reporting servers, job schedulers, all sorts of other things that make up the application that are still stuck on the Windows layer, because ultimately if we can get everything into containers, then we can build the completely scalable cloud-based environment that they're looking for, which will give them a lot more flexibility, and it'll make it a lot easier for us to put it into things like Kubernetes-based services where you have a lot more deployment options also. Looking at automated builds, again, with all the recipes and the stuff that Bronco was talking about with Docker files and repeatable recipes for building the images for your application, those need to go into your build processes and into your CI/CD stuff as well.
And in your version control eventually.
Yes, and all the way out to implementing something like GitOps and actually having Git repos with your configurations of your customer deployment. So whenever you need to deploy something, all of that magic happens once you've put it all together correctly. What can you use your application Docker images for? Well, integration with build pipelines, we've touched on that a few times. Development, distributed project development, spinning up QA environments very quickly, testing stuff and throwing them away, demo environments, production systems, support, testing a certain issue. You need to spin up a certain version of the application, certain version of OpenEdge, certain version of the database. Piece of cake when you've got it all in Docker images. And then one of the really complex things that comes up is your deployment platforms, as Bronco also touched on. Docker and Docker Compose is a nice and easy way of doing things. It's simple, and the approach that we've taken for this project is we want to really walk before we try running. So we define the base components, we use Docker Compose, and the next step is going to be looking at things like Kubernetes and Azure Kubernetes services. In this particular case, because that's what the customer wants to be running on, is the Azure platform for everything they're doing. There may be other things as well. So Azure have something called container instances, but that's something we need to dig into some more and see what fits in with the strategy and what's needed there. Okay, so first of all, a big thank you to Mark Information in Denmark for, this is the project we're working on, but for allowing us to talk about what they're doing here. We're a little over time, but we do have time for a few questions if there are any, and otherwise you can catch us on during the rest of the conference or on emails. If you want to know more about Dockerizing, then Mike Lever and I are doing a presentation tomorrow on Dockerizing OpenEdge applications also, but doing all of this in a web browser and developing in the browser as well. Yes?
There was one question from the chat that came in that asked about when you were doing the uppercasing and lowercasing of things, how did you manage literal strings that you had in the application code, things that were quoted in that kind of stuff?
So like run value statements?
What's that?
Like run value statements? Or
No, just making sure that log messages and error codes and things that were displayed to the user were displayed in a case-appropriate manner.
No, well, the issues we were facing were just primarily the running and the compiling stuff and whatever logging. We haven't run into any issue about what the actual case was so far. So don't know where the question is.
He was talking about log messages and things that would be displayed to the user. If you lowercase everything, there wouldn't be an uppercase.
Yeah, but like I said, via the grep statements, we are pretty specific about what we actually lowercase and what we don't lowercase. So one of the things was there was a lot of excludes. So we did see something which was a suspect, but the program for geologic to assess every situation we encountered just said, okay, well, forget it. It's not relevant.
Did you also consider using xref output for this transformation, which is more context related? Like
No, not yet, because I was, like I said, this was basically for the run statements and the include statements. It was a 4-day job, and I converted everything. And
the next thing we're going to be doing is more of a deep dive into the nitty-gritty application code and actually running it as well, and seeing what happens there. So that happens next week, actually, when we get back.
One of the things I didn't mention was one of the most important things, that we came up with a repeatable solution. So we can do this all over again. So if we move in a new branch which was not converted, then we could convert again and again and again.
Yeah.
So
Okay. Last question?
Starting a new instance takes about 2 minutes, which is not good for running a new instance or quite a long transfer on the as-needed basis. So do you have an idea or some way how to improve this feature? Or
Yes.
is it technically impossible?
No, we have some ideas, because we've starting a PASOE instance in this particular case takes a couple of minutes. We have a few things to look into. One of them is that if you have the WAR file in the web apps directory, then every time you start an instance, it gets redeployed. And if you take it away once you've installed it, then some things might start up. But there may be some application-specific things that are happening that are making the service take a long time to finish. So that's part of what we'll be looking at.
Did you think about splitting the logic into several different containers?
Well, we want to try and get the logic at least for PASOE to be as specific as possible, but the big challenge we had was we start with one very big code base where there's no separation in directories or in any other way of everything's mixed, because it's traditionally a client-server application that's become an app server-based application. So ideally, yes, but it's going to take some time before.
Yes, I understand. Thank you.
All right, good.
Thank you, guys.
Thank you very much.
thank you.